evening and welcome to Tinkering with Edkelar. For this time, I dug out another one of my tube projects that have piled up. It is a Precision brand RF signal generator. These were used to provide test signals to AM receivers. This particular model, E200, has been produced over several decades, resulting in about half a dozen of different revisions. They mostly differ in the number of bands they offer. My unit here is from a later bunch and has a band selector from A to G, where the last update I found mentions band H. I acquired it as a repair project, which seems a bit of an understatement. It was missing a knob on the selection switches and also the knob for the frequency dial. The latter is probably still connected to the axle, which has snapped off. Taking the device apart shows that the inside looks much better than the outside this time. Quite a pleasant surprise, but there are still a few old capacitors to be replaced. The transparent plastic that has the indicator line is warped, and judging by the hole pattern, it has also shrunken quite a bit. Yikes! The power line between the RF filter box and the transformer was a bit toasted. The insulation crumbles off on one line and is already cracking on the other. Something got hot. The carry handle is a leather strap with two metal brackets. The leather is falling apart and the brackets were the most rusted part of the whole thing, so I scouted for a replacement. The case had a sizable bend on one edge. Looks like somebody tried to open it with a screwdriver at some time. Let's fine-tune the linearity adjustment of the sheet metal. That is to say, whack it with a hammer until it's straight again. The original paint was rather thick, but missing in quite a few spots. I sanded off most of it. Eventually I need to set up a sandblasting jig. I would have preferred to start with a clean slate here, but at least I got the rust removed and the surface flattened out just enough so that it's smooth. A fresh paint job later, the case is starting to look almost as good as new. When inspecting the frequency dial plate, I saw that the lettering is recessed, which means I can sand off the top layer to make it look nice again. The front plate got some good cleaning as well, and I also tuned its linearity, so now it's a flat panel again. A tad bit unusual for the period, but this device has quite an elaborate line filter. It also changed with the revisions, and mine has the high-end revision with 2 series inductors and 2 sets of capacitors. Thou shalt not leak RF2 mains. The tuning capacitor needed serious attention. When I got the device, it wouldn't even turn for all the gunked up grease. I disassembled it so I can clean and re-grease the mechanism. Interesting fact, it has a ball bearing based reduction inside the axle. You turn the inner peg about twice as far as the capacitor will turn. First time I saw that construction. To replace the broken axle, I looked at the various materials I had around and decided that none of them was viable. Either they were too brittle, too soft, or a weird combination of both. I ended up using a large comb prop and cut out a bit to whittle into shape on the lathe. For the first missing knob, I tried some resin, but that didn't go well. I borrowed another one from one of the pending projects instead. The tuning knob has a different design. Thanks to OpenSCAD and some creative scripting from yours truly, I now have a nice replacement. It might be a tad bigger than the original, but it works fine and looks the part. A few resistors turned out to be way out of spec too, including one that measured 74K instead of the 47K that it should. Being borderline dyslexic is not helping here. the potentiometers get some cleaning and lubrication. The band selector assembly is a construction that Precision was very proud of. They call it their Union Oscillator. It attaches the coils and capacitors as well as the tube that provides the RF signal directly around the rotary selection switch. Only the tuning capacitor is wired up from the outside. All the unused coils are grounded to prevent any interference. This ultra-compact 3D design makes troubleshooting and soldering extremely difficult. I did, naturally, rewind the transformer again. The burnt up wires were suspicious. As with the previous Precision devices, I replaced the plug-in sockets with 4mm ones, which are more common these days. The output stage is in a shielded box. There are two parallel potentiometers to help fine-tune the output voltage and a set of RF connectors, one of which hides a resistor, so you have a high and a low level output. I considered replacing the RF connectors with modern versions too, but then I found a source for the connectors to make some cable and decided to keep the style. I love the screw-on caps. DC filter cap was a 3-in-1 design. I opted for my usual gut and stuff strategy. The new caps just barely fit, but there shouldn't be much of a problem. I keep the wires inside the heat shrink tubing anyway, unless they are the common negative that needs a connection to the can anyway. There also was a 3K resistor where one of the legs broke off. I replaced it with 3 1K ones to get close to the original value and power rating. The tube also does the AM mixing of the audio signal, and it amplifies the result quite a bit before sending it off to the output can. I also recreated the indicator plastic from scratch. It took 2 tries to get right, but much better than the original. As usual, I first turn on the mains voltage without the tubes to double check the heaters and input voltage wiring. Check. Next, I add the rectifier tube to check the DC output. Check. And then Owie! Okay, without a load, the close to 300 volt DC will linger quite some time, even inside a measly 10 microfarad capacitor. That's smarts! The initial test with all the tubes connected showed that the 400 Hz audio signal was a bit off, 360 Hz only, but no sweat. It's just a test tone anyway. No need to fuss about accuracy here. There aren't even any tuning elements provided. What was much more annoying was that the RF output was a flatline on all bands. I poked and prodded on various locations, replaced some more resistors that were slightly out of range. Nothing. Only when I moved a mica capacitor that was blocking my view, I realized that moved a bit too easy. And yes, one of the legs of the capacitor was broken inside the case. It looked fine, but wouldn't function. And since it couples the oscillator signal into the tube, well, no wonder there wasn't anything going on. After tuning in the frequencies and the RF modulation signal, it was almost done. Adding the new carry handle, and after closing the lid, a final touch, the tuning knob. So far, so good, right? Well, there are still 2 issues that I couldn't fix within the project video time frame. Issue number 1, the transformer still gets quite warm, even with the rewinding. I suspect the core sheets to be of less than ideal quality. The device consumes about 25 watts, and this size transformer should be able to handle double that. Also, none of my previous rewound ones got this hot, even after longer operations and higher wattage. So I doubt my wire is the problem. Eddy currents is my best guess. I'm scouting for replacement sheets to restuff the thing, but those are hard to come by. Issue number 2. While I got the oscillator well aligned for the lower bands, the upper two bands, F and G, are not working quite as well. The F band is misaligned at the lower end of the scale, but works overall at least. The G band, however, is only working about 2/3 of the upper range. The lower portion cuts in and out randomly when I so much as bump the tuning capacitor. I couldn't find any reason for that. All the contacts measure fine and the lower bands work flawlessly. Anyway, even if it is not yet perfect, I hope you enjoyed this tube device project. I got a few more in the random pile of things. See you next time! The transparent plastic, darn it.